Welcome to Gridstore Energy's presentation of our exciting new SolarBoost grid-scale battery technology. SolarBoost is the only product in the world to simultaneously solve the problems of negative prices at midday for solar farms and the power imbalances between solar panel production that cost up to 15% of power production. SolarBoost is a 1.5 kilowatt-hour plug-and-play battery installed in parallel under each solar panel in a solar farm. In this diagram, we can see an older solar farm where the top right-hand panel is only producing 490 watts, less than the rest of the panels in that string. Without SolarBoost, the excess power produced gets sent back to the lowest producing panel and wasted as heat, increasing the rate of degradation of that panel and reducing its output at an increasing rate over time. SolarBoost allows us to store that excess power to the SolarBoost battery and discharge it at a later time. SolarBoost has some key advantages. Firstly, saving that 15% of additional power from solar panel imbalances, which in 2023 in Australia was worth up to 31% additional net profit. And because we sit behind the inverter and don't change the connection with the grid, no additional approvals are required. And on retrofits and new installations, we use the same infrastructure as an existing solar farm with no additional requirements. Some additional benefits of SolarBoost include increased panel life, and with a microcontroller under each solar panel, we're able to monitor in real time the production of every panel in a solar farm. This allows us to undertake preventive maintenance, both for solar panels and our own swap and go SolarBoost units. And importantly, when installing, as soon as a string has been installed, it can be commissioned and start charging immediately.
This is the SolarBoost energy storage system, and we're looking at a smaller version that we've had under trial for several months. So on the roof we have a PV panel or solar panel that supplies power to the SolarBoost via the standard MC4 connectors. The power then enters the SolarBoost in through the circuit breakers and then across to the relays, and the relays control the direction of power that either coming into charge the battery or going out of the SolarBoost to discharge the battery. After the relays select the mode, it then goes up through the MOSFET, which controls the amount of power coming into the battery, and then through the battery charger and then down to charge the battery. When we go into discharge mode, the relays switch over again and the power exits the SolarBoost via MOSFETs and also a DC-DC controller here. That not only, well, this combination not only allows us to control the amount of power exiting the SolarBoost, but also the voltage of that power. And this allows us to do balancing of all the solar panels in a string, and by providing a much higher voltage, it allows us to override other voltages from other solar panels, and that balancing can increase the power output significantly increase the power output of the entire string. There's also two power meters, and they're reading the voltages and power coming into and out of the solar panel, which also then tells us how much battery life or the state of charge of the battery. And finally, we have a ESP32 microcontroller